Hey everybody, the quadratic formula can be pretty tricky. So in addition to the Khan Academy video and my video that I posted for you yesterday, I wanted to show you two more videos today. These are examples that I want you to add in your interactive notebook along with the example that you did yesterday. So really this should be examples 2 and 3 because you already put one in your interactive notebook. So here we go. First, let's use the quadratic formula to find the zeros or the x-intercepts of the parabola x squared plus 5x plus 6. So the first thing that I need to do is identify A, which in this case is 1, and B, which is 5, and C, which is 6. So now I have identified A, B, and C for my quadratic formula. So now I'm ready to sing my lovely little quadratic formula song here. X equals opposite B plus or minus the square root of B squared minus 4AC. That made me out of breath. All over 2A. So now when we're dealing with something like this, it can be really overwhelming to look at all the parts at once. So I'm going to start with the expression that is under the square root symbol here. So 5 squared is 25, and 4 times 1 times 6 is 24. So I can rewrite it as 25 minus 24. And at the same time, I'm also going to clean up my denominator. 2 times 1 is just 2. So keep in mind that no matter how complex the expression is, we're still going to be using that order of operations. So I dealt with what was under the radical first by dealing with my exponent here, squaring, and then multiplying. So now I'm ready to subtract under my radical here, and I have the square root of 25 minus 24, so that's just the square root of 1. So now it's negative 5 plus or minus the square root of 1, all of that divided by 2. Now the square root of 1 is 1, so it's negative 5 plus or minus 1 over 2. And this gives me my two possible solutions. So this is the point at which I am going to take these quantities and I'm going to separate them into two separate expressions here. So I'm going to have negative 5 plus 1 divided by 2 and negative 5 minus 1 divided by 2. Negative 5 plus 1 is negative 4. Negative 4 divided by 2 gives me negative 2. Negative 5 minus 1 is negative 6. Negative 6 divided by 2 gives me negative 3. So my two solutions here are x equals negative 2 and x equals negative 3. Now remember, the meaning behind this whole crazy process for us is that the whole meaning behind it is that these x values are where the graph is going to pass through or touch the x-axis. So keeping in mind, this was the original function that we started with up here, f of x equals x squared plus 5x plus 6, and our two solutions were x equals negative 2 and x equals negative 3. When I go to graph these in Desmos, it is going to look like this. So I typed that expression, y equals x squared plus 5x plus 6 in, and I'll notice right here the two places where this graph touches the x-axis, its two x-intercepts, are negative 2, 0 and negative 3, 0, which is exactly what we got when we did those calculations using the quadratic formula. Hope that first example helped you out a bit. So let's look at a second example. You will not believe the contraption I have here that is helping us. Give it a second to refocus. All right, whoops. I'm just gonna adjust so we can see our second example here. Let's look at this second example. F of x equals negative x squared minus 2x plus 48. So same idea as last time. My first initial step must be to identify a, b, and c for this particular quadratic. A is negative 1, b is negative 2, and c is positive 48. Once I've taken the time to identify those coefficients and that constant, I can sing my little quadratic formula tune here. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Notice that in this case, opposite b is going to end up being a positive number because b is initially negative. Now, just like last time, I'm going to start by simplifying what I see going on inside my square root right here. So the first thing I'm going to do is I'm going to take my negative 2 and I'm going to square it. That will give me a positive 4. And then I'm going to take my 4, my negative 1, and my 48, and I'm going to multiply them together as well. So when I do that, I get 2 plus or minus the square root of 4 minus negative 192. All over 2 times negative 1, which is negative 2. So my next step is going to be to take the 4 and subtract the negative 192 from it. Remember, subtracting that negative is the same as adding. So I can think of this as 4 plus 192. So I get 2 plus or minus the square root of 196 divided by negative 2. So far, so good. The trickiest part is generally finding and taking the time to simplify this component. Make sure that you're utilizing the calculator features in Desmos or a graphing calculator to assist you with that. So now I'm ready to take the square root of 196, which happens to be 14. So this is 2 plus or minus 14 divided by negative 2. Now I'm ready to break this apart into my two possible solutions. So I have x equals 2 plus 14 divided by negative 2, and I have x equals 2 minus 14 divided by negative 2. 2 plus 14 is 16. 16 divided by negative 2 gives me negative 8. 2 minus 14 is negative 12. Negative 12 divided by negative 2 gives me positive 6. So the quadratic formula has now given us the two solutions for this quadratic equation, which is simply another way of saying it's the two x-intercepts for this particular graph. And so we started with the parabola, the quadratic. F of x equals negative x squared minus 2x plus 48. And we determined that its two zeros, or its two x-intercepts, are located at x equals negative 8 and x equals 6. Now, just as I did in the last example, here is the graph of the function that we just created, and here it is in Desmos. I have to zoom out a little bit so that you can see it here. But you'll notice that it does, in fact, have an x-intercept or a 0 here at negative 8, 0. And it also has an x-intercept or a 0 at 6, 0. And so we just simply confirmed what we can see on the graph using this algebraic formula. I hope this stuff is helping. Keep working hard, keep asking questions. I'm here to support you and help you to figure all this stuff out. Keep up the good work.